Really simple scripts. That's what I'm doing now. I should have done this years, months ago, I should say. I started this, but basically going through Ron Cheng's book Rhino 5, great text to pick up. Instead of learning it in CAD, you may as well learn it through your skills in Grasshopper. So what I've done here is I've got a little baked form here. I'll get rid of it. You can see the parametric model. I pared this down to basically as simple as I can make it. And it's a very easy script to take a look at. So let's take a look at it in a couple of minutes because that's all it really takes. What I did was I went in, I'm going to take this off, ungroup. I went in and I made, once again, a point. Let's get this off. And, well, I made a helix, which is not so hard to make. You have to put in a point and multiply it. I multiplied everything by pi just to give it a good value. It's a range that comes through, and you said that the x coordinate multiplied by pi I thought was a good thing to do. You'll see why I did that in a minute. So you've got a value of whatever range is in there, and actually I have 10 times pi steps, 100 steps, so there'll be 100 points through my range, which goes into x multiplied by pi again. So then I take my sine factor to y and my numbers to 10 pi into z through the cosine. Then I have an interpolated curve, and there it is. There's my interpolated curve. You want to make that first. I did a polar array of it, and I chose to use a certain amount of count, which happened to be 9, which I can change out to whatever I want. I can change that count to whatever I need, and I hadn't played with that parametrically yet, but there's our item that I'm basically going to flow along another curve. So I need to make that other curve, and so it's situated here along 0 to 0, 0, 0 to a high digit, probably 100, 0, 0 as a point. Make a line that goes from there to there. That's going to be my base curve that geometry is going to follow, and I'm basically putting that onto a target curve. And my target curve is I generated a center box which held the same values, 10 by 10 by 10. It then makes a region of up to whatever amount of points you want seeded. So you have all these points, and as long as you change those, I then interpolate those. So if I want to change those interpolated points, I just put more into the equation. If I wanted more all the way up to 10, that'll be fine. It gets a little jumbled. I think it looks good around a half dozen as a kind of curve. And then I've got a seed to change that curve to whatever I want. And as I change that curve, I try not to get it too close to itself, but you'll see why. I flow it along that line. That geometry follows that baseline to that target, and I end up with this, which is really, really nice and very fast-moving script. It slows down a little bit with the pipe, and I'm able to, as long as I match my degrees is high enough for your point count. If this degree is at 3, I want my point count to be a little higher, so I set my minimum point count to 4. This can only go down to 4, otherwise this bugs out a bit on me. Really nice example, so let's crank that up to wrapping it 10 times or whatever you want. You can wrap it 5 times. It doesn't matter to me. It follows around that initial curve, so I pipe the initial curve and I pipe the other ones. You've got your center wire along with your other ones around it, and if you actually want to see your wires, just bring your count down, probably your polar array count down, so you can see 3 wrapped around that wire, and you got some very nice parametric control of a electric cable, and that's all I did. I then did a division by radius in here, so it stay parametric with whatever size I end up setting this to, so it kind of shrinks. And you can see that there's a problem with the length of it coming into this. It works well at 10 count with multiplied by pi in the x, so you can just leave it at that length for now if you want. You have to adjust it if you make it a little longer and shorter. Really nice. So just take your wraps up, take your point count up, whatever you want. Let's stay at 4. Actually, I like odd numbers when I'm doing polar arrays for some odd reason. Get it, and then the count, I can change whatever I want in that box, and I can wrap this cable anywhere as it hits itself. If it becomes coincident, I usually change the design. Otherwise, I've got a really good control over a parametric electric cable. I could have made one iteration of it, but why not wipe the script that I can make as many iterations as I want and flow this cable between any 2 points? And this is, once again, the way I script is I do not want to have anything coming in out of the Rhino. I don't need a 3DM file. If I want a 3DM file, I'll take an iteration I like. I'll send it to bake, choose whatever amount. If I want to group them, I can do that. It takes a second to bake, and there you go. Leave this page, and you're in here for a nice little render. And there you go. Whatever you ended up wanting to do, technical I actually like the artistic, still one of my favorites, but even line drawings, I doubt I would sit and draw this thing. So if you actually want some nice flat works or patterns to send to a CNC to mill out shapes, this is endless to what you want to do with it. I'm going to go on to the very tricky, what's my next assignment? The spoon. So look forward to that today, hopefully. Thanks for watching.